So, we've all spun up virtual networks in the cloud, right? But out of the box, they're basically their own little isolated islands. The real magic happens when you start connecting them. So, how do you build those bridges between your networks securely and, efficiently? Well, that's exactly what we're going to dive into today.
And this, right here, is the core challenge. In any real-world setup, you're going to have multiple separate networks. You'll have one for dev, one for prod, maybe one for shared services. You end up with all these digital islands. And the big question is, how do you connect them without just, throwing open the doors to the public internet?
Let's call this what it is, the island problem. By default, a virtual machine in your development network has no idea how to see a server in your production network. And look, that isolation is a fantastic security feature, but it becomes a huge roadblock the second those two things need to talk to each other. Let me give you a classic real-world scenario. Let's say your manufacturing apps are running in their own dedicated network, but your core IT services, things like Active Directory for authentication, they live in a totally separate network. Well, the moment that manufacturing app needs to authenticate a user, it tries to reach out, and it can't. Everything just grinds to a halt. Now, I know what you might be thinking. The tempting, kind of easy fix might seem to be routing that traffic over the public internet. But let me stop you right there. That is a terrible idea. It's slow, it can get really costly, and most importantly, it's a massive security risk. We absolutely need a private, fast, and secure alternative. And that brings us to the proper solution, virtual network peering. The best way to think about this is that we're literally building private, high-speed bridges between our network islands. All the traffic that crosses these bridges stays on the secure Azure backbone, completely walled off from the outside world. So what does this actually mean? Well, the key thing to get here is that when you peer two networks, they start acting like they're one single private network. Traffic flows directly between them over Microsoft's massive global backbone. It never, ever touches the public internet. And what does that get you? Incredibly low latency and huge bandwidth. Now, peering comes in two main flavors. You can connect networks that are in the same Azure region. We call that regional peering. Or you can connect networks clear across the globe, say from the US to Europe, with what's called global peering. Functionally, they're pretty much the same, but you will see a small data transfer cost for that global traffic, which makes sense because it's traveling a whole lot farther. So beyond the speed and privacy, there is a critical security feature you have to know about. Peering is non-transitive. What does that mean? It means if network A is peered with B and network B is peered with C, A cannot automatically talk to C. This isn't a bug, it's a feature. Each connection is a direct, explicit link that you create, which gives you this incredibly fine-grained control over who can talk to whom. Okay, so our bridges are built, the networks can see each other, but now we need to direct the traffic. How do we play traffic cop and force data to follow specific routes, maybe for a security inspection or to access some shared services? Azure's default routing is pretty smart. Once you peer two networks, it automatically figures out how to get traffic between them. But what if you don't want the default? What if you want to force all that traffic to go through a central firewall first? Well, the default route isn't going to cut it. You need to take manual control. And this is where user-defined routes, or UDRs, come into play. Honestly, the best way to think of a UDR is as a custom road sign. You're putting up a sign that overrides the default highway, telling traffic, nope, you can't go that way, you must take this specific exit, forcing it towards a specific next stop, like a firewall appliance. So when you combine this peering with these UDRs, you can build a really powerful and super common architecture, the hub and spoke model. It's simple. Step 1, you set up a central hub network for all your shared stuff, like firewalls and gateways. Step 2, you connect all your other spoke networks to that hub using peering. And step 3, you use those UDRs to make sure that if one spoke needs to talk to another, that traffic has to pass through the central hub for inspection. It makes management way simpler, centralized, and very, very secure. And here is a pro tip that makes this whole hub and spoke thing incredibly cost-effective. Instead of putting a pricey VPN gateway in every single one of your spokes, you just put one in the hub. Then you just have to enable 2 little settings. It's like a handshake. On the hub side of the peering, you check the box for Allow Gateway Transit, and on each spoke side, you check Use Remote Gateways. With just those 2 clicks, all of your spokes can now share that single central gateway. It saves a ton of money and complexity. All right, we've designed it, we've built it, but how do we know it actually works? And maybe more importantly, how do we know it's secure? This final phase, the verification part, is absolutely critical. You can't skip it. Think about it. You've just changed a dozen settings across multiple networks. You can't just cross your fingers and hope for the best. You need a proper toolkit that can tell you, definitively, is the path open between these two machines? Are my firewall rules working as I expect? Where is the traffic really going?
And that toolkit is Azure Network Watcher. This thing is your command center for network diagnostics. You can literally visualize your entire network topology. You can troubleshoot a connection between two specific VMs. You can even run a simulation to see if a certain kind of traffic would be allowed or denied by your rules. It lets you verify everything end to end, even before you deploy a new application. It's a lifesaver.
I heard a great way to think about security in all this, and it really stuck with me. Think of peering as just opening a door between two rooms. But just because the door's open doesn't mean it's a free-for-all. You still need security guards, and in our case, those are network security groups or NSGs, standing at that door, checking every single packet to make sure only authorized traffic gets to come through. Security here is all about layers. It's not just one thing. You start with those NSGs for your basic filtering of ports and IPs. Then you can add a centralized Azure firewall in your hub for more advanced intelligent threat inspection. And then you enable NSG flow logs so you have a complete audit trail of every connection that was allowed or denied. Always remember, connectivity and security have to go hand in hand. And that really brings us to our final question. Building this is one thing, but networks are never static, right? Configurations change, new apps get deployed. The real challenge is making sure that the secure, efficient network you built on day 1 is still just as robust and secure on day 100 and day 500. It's a continuous process of monitoring, testing, and verifying.
Hey everyone, so in this lab we are going to implement Intersite connectivity, and if you look here, the tasks we are going to do, there are 6 tasks. First task is to create a virtual machine core service VM under that core service VNet, then create a second VM manufacturing VM, that's a different network, manufacturing VNet. Third task is to use network watcher to test the connectivity in between these two VM. Fourth task is configure virtual network peering between different virtual networks, so core service VNet and manufacturing VNet. Task 5 is use PowerShell to test the connectivity or connection between these two virtual machines. And task 6 is create a custom route. So let's start that one now. First we need to connect to the portal. So here I have already connected, and then search for VNet. And check for VM virtual machine. So now let's create VM. So click on create virtual machine. So that's subscription, then select the resource group, then give a virtual machine name, select region is TOS, select region in your case, whatever region is. Availability option, select that no infrastructure redundancy required. Security type, select the standard. Image, for image we are going to select, so we are going to select Windows Server 2025 data center x64 Gen 2. Select whatever choice you want. For lab purpose I am selecting this one. Then VM architecture x64, and size is D2SBA3. Username is local admin. Give a password, complex password. Note this password because we may need this one to connect later on. Public inbound ports, select none. Next, under disk tab, we are considering all the default values, but you can see that on what are the options available: disk encryption, OS disk, and OS disk size, type, um, when you delete VM with this storage will delete or not. Key management, there are different options: platform management or customer key management, or both options. Then select additional disk if you want, but we are not changing anything here. Click next. So here we are going to create a network information VNet. So for that, uh, select edit like new one. So filter option, but if you go here, so edit virtual network, select that one, give a name for virtual network. Now delete this. Okay, let's first add the address range. Delete this subnet. Add a subnet. Give a subnet name. Select the subnet address range. Click add. Click save. Then next, management tab. Consider all the default value, but you can check all the options. Select monitoring tab. So here you see that boot diagnostic is enabled, which we don't want that one for our lab environment. So select disable. We're not going through any advanced level settings or tags. Just click on review and create. So running validation in progress. So click on create. So when that in progress, let's open a duplicate tab so that we can proceed with the second VM. So here subscription, select subscription, then select resource group, give a virtual machine name. This virtual machine name we are going to give manufacturing VM, and that's in East US. Availability zones, select no infrastructure redundancy required. Security type is standard. Image is we have selected Windows Server 2025 Data Center x64 Gen 2. Then size is D2SB3. Username we are giving local admin. Giving a complex password. So public inbound port, select none. On the disk, we are considering all the defaults, networking. mm, Click on edit virtual network. So this VNet name we are going to give that manufacturing VNet. Address space is 172.16.0.0/16. Delete this, create a additional subnet, but you see that for VNet you must add at least one subnet for the virtual network. So subnet name we are giving that manufacturing subnet, and starting address is 172.16.0.0/24. Select add, save. Then management we are considering default value. Monitoring tab, make sure that booked diagnostic is off, disabled. Then for advanced and tags we are taking default one. Now click review and create. Let's go back to other one by the time. So deployment is been completed. We can go there. This is the first VM, core service VM. And here validation pass, select and create. So you can see that the first VM is ready, up and running. So let's wait to second VM become available. So our second VM is also ready. So manufacturing VM and core service VM. So now we are going to use the network watcher to test the connection between uh, virtual machines. So from that, from this portal, search for network watcher. So from this section, you can see that monitoring options. There is also like connection monitor, you can watch that one. Then there is also diagnostic tools. In our case we are going to observe the connection between these two. So under network diagnostic tool, select connection troubleshoots. So here source type is virtual machine, and select the virtual machine. So from core service VM, and destination type is destination also, like we know that it's a virtual machine in our case, and select the virtual machines. So that is manufacturing VM. And preferred IP versions is both TCP and ICMP protocol. And then destination port is that RDP protocol, so 3389. Source port empty. Diagnostic test is in the different options, so we are considering the default one, what is theirs. Then select that run diagnostic tests. It may take minutes or couple of minutes, so let me come back when we get the output. So here we can see the output of that diagnostic test, and it's showing that it's actually unreachable. Uh, so this makes sense because the virtual machines are in different virtual network. So for that, now let's configure virtual network peering in between these two VNets. So for that, let's search for, okay, let's open another tab so that we can run this one again and compare that one. So search for core service VNet or VNet. go to core service VNet, and here under settings you will see that peering. Select peering, then click on add button, give a peering link name. So we are giving manufacturing VNet to core service VNet, and subscription select virtual network. So select manufacturing VNet. Then here manufacturing VNet to access core service VNet, select that one, and also manufacturing VNet to receive forward traffic from core service VNet. So select that one also. Here pairing local virtual network summary. So pairing link name. Select core service VNet to manufacturing VNet, give any meaningful name. And here so core service VNet to access manufacturing VNet, and that is default selected, and allow core service VNet to receive forward traffic from manufacturing VNet. Select that one and then click add. So we can see that network peering has been set up. So here we can see core service VNet to manufacturing VNet is listed here. So if we refresh the page, we can see that also it's showing that they are connected. So now let's this is for core service VNet. So let's check for manufacturing VNet. If I go to manufacturing VNet and select the peering section, we can see that also said like already connected. So now let's go to the PowerShell to test the connection between virtual machine. So from Azure Portal, so now search for VM. First we'll go to core service virtual machine to get the private IP address that will check the connection. So if you go the networking section under overview tab, this is the private IP address. So you can copy that one. And let's go back, go to the manufacturing VM, and under operation, you will see that run command. Select that option, and there are different run command that you can use. In our case, we are going to use run PowerShell script, and going to execute test net connection command. Private IP address is if we execute that one, here you can see that cell is execution in progress. So wait for this to be completed. So here you see that test connection is succeeded. So now if we go back, we do not need to execute, just for the checking. So if we run diagnostic test this time, we should not see that error message, because this time it looks good, no issues. And you can see it's all reachable and no issues at all. The last task that we are going to create a custom route, like we want to control network traffic in between the perimeter subnet and the internal core services subnet. And for that, a virtual network appliance will be installed in the perimeter subnet, and all traffic should be routed through that one. So now let's search for VNet or core service VNet. Select subnet, click on here subnet, and then give a name. We are giving the subnet name is perimeter. Giving the range, click add. So subnet has been added under that core service VNet. Now here search for route table. Click on create button. Select subscription, select the resource group. Region East US, give a name, route group, route table name. Propagate gateway routes is no. You're not giving any tags, so just click on review and create. When review done, click on create. So now route table is created. Now select on go to resources. So we can see, let's go back to route table. Search for the network table or route table that we have created. So select that route table. So under settings, select that routes, click add, and create a route. Okay, give a route name, and destination is IP address. Destination IP address is our core service virtual network, which is that VNet IP address for core service VNet. And next hop is virtual appliance, and we are giving next hop is that like in future that we are thinking like virtual appliance IP will be like this 10.0.1.7. So select add, So route rule in place. Now we have to associate this with uh, subnet. So select the subnet here and then click on associate, and then we need to select that virtual network, which is core service VNet, and subnet is the core subnet. So click on OK. So we have done this part now. So we have completed every task of this lab, um, and it's always best practice or recommended into a lab environment um, to delete the resource group so that it does not incur any additional cost. And for okay, that's all for this lab. If you have any comments, please add into comment section. Otherwise, see you in next lab.